Hi, I'm Al-Ibadi from the University of Basra. I would like to present our paper entitled The Temperature Effect on the Characteristics of the Dielectric Elastomer Actuator by Al-Ibadi and Mohammed Al-Atwani from the Computer Engineering Department, University of Basra, Iraq. This type of actuator is used for design, soft robotics, and too many another applications. The dielectric elastomer actuator is usually made from soft elastomic membranes as sandwich with two electrodes. As shown in this figure, the yellow shows the DE and the light blue shows the electrodes. The dimensions of the DE and the electrodes affect on the actuator behavior. In this paper, we have used the VHB 4910 made by 3M as the shape and dimensions as given in figure below. 5 cm in each side as a square shape for the DE and 1 cm side for the Cooper as electrodes. The DE is cut as a square of 2.5 cm in each side and then stretched by a pre-stretch ratio lambda equal to 1, which is mean 100%, where lambda equal to L minus L naught divided by L naught. L represents the total length, the side length after pre-stretch. L naught is the initial length of each side. From equation 1, we can calculate L, where L equal to L naught times 1 add lambda. So after pre-stretch, we get the dimensions of 5 cm as shown in this figure, and we fixed the DE at a square as shown here of 5 cm each side. The 1 cm electrode is also adjusted and fixed at both sides of DE. The material constant epsilon r can be calculated from equation 2, which equal to small a square root v square minus v square divided by lambda square f vc, where a is a constant, v is the total applied voltage after the pulse transformer, vc is the voltage across DE, lambda is the pre-stretch ratio, f frequency, and a can be calculated from equation 3, which equal to d naught, the thickness of the DE before the stretch, divided by 2 pi epsilon naught r, and r is shown in the circuit at this position. So we have used this circuit from the input DC voltage 0 to 5, applied to the pulse transformer, which it gets 0 to 50 kV. When we change the value of R, we get different frequencies. The main aim of this paper is to study the effect of the environment temperature on the DE constant. So this figure shows the dielectric constant as a function of frequency, which is vary from 100 Hz to 20 kHz at 3 different temperatures: 20 degrees Celsius, 50 degrees Celsius, and 80 degrees Celsius. In this figure, The effect of the temperature is less, as we show here, at the high frequencies. The second figure shows also the dE as a function of temperature from 20 to 80 degrees Celsius at 3 different frequencies: 500 Hz, 1 kHz, and 5 kHz. Also, we can see when the frequency is high, 5K, the temperature has low effect on the dE. So from these results, we get the equation 4 to calculate the epsilon r, which is equal to the first part of epsilon r as the previous equation, but we have added the temperature effect as the second part shown here. These two figures showing the dE at 40 degrees Celsius and at 80 degrees Celsius as a function of a frequency from the equation 4 and the experiment data. As a conclusion, this type of actuator is widely used to design and implement the soft robotics and many other applications, and may be used at different environments. So we aim to study the impact of the environment temperature on its characteristics. So in this paper, the effect of the environment temperature is studied on the dE of VHP 4910 made by 3M. The dE is breath-stretched by 100%. So the breath-stretch value also affects on its dE and its behavior. The temperature is adjusted at different values from 20 to 80. So we have put this dE at the box and we heated this box from 20 to 80 degrees by 10 degrees Celsius steps. The experiments show that the effect on the temperature can be ignored at frequencies more than 10 kHz, and it has a significant impact at low frequencies. So if we use these actuators at environments of low temperature or high temperature, it doesn't matter if the frequency is more than 10 kHz. And from the experiment result, this paper proposed a model to calculate epsilon r, as shown in equation 4, as a function of operating frequency and take an account of the environment temperature. So as future work, the presented model can be used to select the operation points for the actuators. Finally, I would like to thank the University of Basra, the Computer Engineering Department, for their support to provide the facilities, equipment to make this paper. And also thank you very much for your attention. Please, for any questions, please send an email to the authors at the following email addresses.